Hi, hello, welcome back to my YouTube channel. So today we are going to discuss gamma distribution second kind. This is another important question in unit 4 related to semester 2 Kakatiya University, or else other universities also may be having the same syllabus. Okay, so gamma distribution second kind, this is also called as gamma distribution with two parameters. Okay, here in second kind we are going to have two parameters. Okay, parameters in the sense I already told you that which we can able to find out. Okay, that is called as parameters. So now let's see what is the definition. A continuous random variable x is said to follow gamma distribution of second kind. Okay, now since it is continuous distribution, so that's why we have to take that a continuous random variable. Okay, x is said to follow gamma distribution of second kind with two parameters. So this is second kind, that's why it will have two parameters. Okay, a and lambda. Okay, the parameters are called as a and lambda. If its probability, PDF in the sense what? Probability density function is given by f of x equals to a to the power of lambda by gamma of lambda into e power minus ax into x to the power of lambda minus 1, and its limits are x always should be in between 0 to infinity. That means here only positive values are considered. And a comma lambda, okay, a comma lambda always it should be greater than 0. It should not be equal to 0 or else less than 0. Okay, so and the next is gamma integral. This gamma integral will be used in moments. Okay, so gamma integral 0 to infinity e power minus ax into x to the power of lambda minus 1 dx equals to, if it is in the form of this, we can write gamma of lambda by a power lambda. Okay, so again gamma of lambda means we know already, we did many moments. Gamma of lambda equals to lambda minus 1 into gamma of lambda minus 1. We can write like this. So this is the formula for gamma of lambda. Okay, now let us see the moments of gamma distribution second kind. Moments we'll see. Moments. So we all know that first is non-central moment. So non-central moments. Non-central moments. So mu r dash equals to, what is the formula for mu r dash? Expectation of x power r. Okay, so this can be written like this: integration 0 to infinity x power r into f of x dx. But f of x dx, we know that we have to write this one. This is gamma distribution second kind, so we have to write f of x. This formula we have to write in place of f of x. Okay, so integration 0 to infinity x power r into f of x in the sense what? A power lambda by gamma of lambda into e power minus ax x to the power of lambda minus 1 dx. Okay, so now here we are doing integration with respect to x. That means gamma of lambda we can take it as constant. Okay, so 1 by gamma of lambda integration 0 to infinity. First we'll write this one. A power lambda also we can take as constant. Why? Because this also not having x term. No? So a power lambda by gamma of lambda into integration integration 0 to infinity e power minus ax, and here x both are, here we are having bases are equal, exponent should be add. That means x to the power of lambda plus r minus 1 dx. Okay, so See, if we compare this formula and this formula, it will be in the same format. See once. Integration 0 to infinity, here we are having, and here also we are having integration 0 to infinity. Here e power minus ax, here also we are having e power minus ax. And again x to the power of lambda minus 1, here also we are having x to the power of lambda minus 1. But in place of lambda, this is total lambda, okay? So both are in the same format. So that's why we can write here a power lambda by gamma of lambda into this one we can write. Gamma of lambda means what? Gamma of lambda means what? Lambda plus r by a power lambda. Lambda means what? Lambda plus r. We can write. Okay. So this is what we can separate this term. Okay. So a power lambda by gamma of lambda into gamma of lambda plus r by a power lambda into a power r we can write. Okay, so that this both gets cancelled. The final answer is mu r dash equals to, the final term is gamma of lambda plus r by gamma of lambda into a power lambda. Okay, so this is the final term we are having. So now what we have to do is, now we have to keep r equals to, put r equals to 1, 2, 3, 4. Why? Because we want up to 4 movements, no? So this is equation 1. Okay, now we'll do that one. So this is the, so we consider this as equation 1. Okay, so now put r equals to 1 in equation 1. Okay, so mu 1 dash equals to gamma of lambda plus 1. R equals to 1 we have to keep, no, lambda plus 1 into gamma of lambda into a power 1. Okay, in place of r we have to keep 1, no, so a power r. Again this is in the form of gamma of lambda. So gamma of lambda formula is nothing but lambda minus 1 into gamma of lambda minus 1. Okay, so that's why we have to, so what we have to do is, we have to write this term in this way. So mu 1 dash equals to lambda plus 1. Lambda in the sense what? Lambda plus 1. Here minus 1 into gamma of lambda plus 1 minus 1 by gamma of lambda into a power 1 is nothing but a. So here plus 1 minus 1 plus 1 minus 1 get cancelled. So the remaining term is lambda into gamma of lambda by gamma of lambda into a. Again gamma of lambda get cancelled. So the final answer is mu 1 dash equals to lambda by a. So this is the mu 1 dash. Mu 1 dash is nothing but mean. Okay. So the mean is lambda by a. Okay. So now what we have to do is mu 2 dash we have to. So that means what? Now put what? R equals to 2 in equation 1. In equation 1. So mu 2 dash equals to gamma of, see here, gamma of lambda plus r in the sense what we have to keep 2 by gamma of lambda into a power 2. Okay. So again this is in the form of gamma of lambda. So we have to write in this way. Okay. So that means lambda plus 2 minus 1 into gamma of lambda plus 2 minus 1 by gamma of lambda into a square. Okay. So 2 minus 1 is nothing but 1. So lambda plus 1 into gamma of lambda plus 1 by gamma of lambda into a square. So again this is in the form of this gamma of lambda. Again we have to do in this way. So that means lambda plus 1 into lambda plus 1 minus 1 into gamma of lambda plus 1 minus 1 by gamma of lambda into a square. So plus 1 minus 1 get cancelled, plus 1 minus 1 get cancelled. So the remaining term is lambda plus 1 into lambda into gamma of lambda by gamma of lambda into a square. Okay. So gamma of lambda get cancelled. So the final term we are having is mu2 dash equals to lambda plus 1 into lambda by a square. Okay, so this is the final term we are having. Now what we have to do is, now put r equals to 3 in equation 1. So that means what we have to do? Mu3 dash equals to what? Gamma of lambda. R means what we have to do? Plus 3 by gamma of lambda into a power r in the sense what? A cube. Okay. So this is in the form of gamma of lambda. Again we have to substitute here formula. So that is nothing but lambda plus 3 minus 1 into gamma of lambda plus 3 minus 1 by gamma of lambda into a cube. Okay. So lambda plus 3 minus 1 is nothing but 2. So lambda plus 2 into gamma of lambda plus 2 by gamma of lambda into a cube. Again, this is in the form of gamma of lambda. So lambda plus 2 into lambda plus 2 minus 1 into gamma of lambda plus 2 minus 1 by gamma of lambda into a cube. Okay, 2 minus 1 is nothing but 1. So mu3 dash equals to lambda plus 2 into lambda. 2 minus 1 is nothing but 1. So lambda plus 1 into gamma of lambda plus 1 by gamma of lambda into a cube. Here again it is in the form of gamma of lambda. So that equals to lambda plus 2 into lambda plus 1 into lambda plus 1 minus 1 into gamma of lambda plus 1 minus 1 by gamma of lambda into a cube. So plus 1 minus 1 plus 1 minus 1 get cancelled. So mu3 dash equals to lambda plus 2 into lambda plus 1 into lambda into gamma of lambda by gamma of lambda into a cube. Okay. So here gamma of lambda get cancelled. Mu3 dash equals to the remaining term is lambda plus 2 into lambda plus 1 into lambda by a cube. Okay. So now what we have to do is, now put what? R equals to 4. So put R equals to 4 in equation 1. So that means mu4 dash equals to gamma of lambda plus 4 by gamma of lambda into a power 4 we'll get. Okay. So again it is in the form of gamma of lambda. So that equals to lambda plus 4 minus 1 into gamma of lambda plus 4 minus 1 by gamma of lambda into a power 4. So 4 minus 1 is 3. So that means lambda plus 3 into gamma of lambda plus 3 by gamma of lambda into a power 4. So again it is in the form of gamma of lambda. So lambda plus 3 into lambda plus 3 minus 1 into gamma of lambda plus 3 minus 1 by gamma of lambda into a power 4. So 3 minus 1 is nothing but 2. So lambda plus 3 into lambda plus 2 into gamma of lambda plus 2 by gamma of lambda into a power 4. Again what? It is in the form of gamma of lambda. So lambda plus 3 into lambda plus 2 into lambda plus 2 minus 1 into gamma of lambda plus 2 minus 1 by gamma of lambda into a power 4. So 2 minus 1 is nothing but 1. So lambda plus 3 into lambda plus 2 into lambda plus 1 into gamma of lambda plus 1 by gamma of lambda into a power 4. Again, it is in the form of gamma of lambda. Okay, so lambda plus 3 into lambda plus 2 into lambda plus 1 into lambda plus 1 minus 1 into gamma of lambda plus 1 minus 1 by gamma of lambda into a power 4. Plus 1 minus 1 plus 1 minus 1 get cancelled. So the final term is mu 4 dash equals to lambda plus 3 into lambda plus 2 into lambda plus 1 into gamma of lambda by gamma of lambda into a power 4. These both gets cancelled. So the final term we are having is mu 4 dash equals to lambda plus 3 into lambda plus 2 into lambda plus 1 into lambda whole by a power 4 is the mu 4 dash answer. Okay, so now what we have to do is we have to do now central moments. Okay, central moments we'll do. So central moments. Central moments. So central moments, first one we'll have mu1 equals to 0. Okay, so mu2 equals to variance. Mu2 equals to what? Variance. Formula is mu2 dash minus mu1 dash whole square. Okay, so mu2 dash in the sense lambda plus 1 into lambda by a square. Okay, minus mu1 dash is nothing but lambda by a whole square. Okay, so in both the terms a square is the LCM. So lambda into lambda square plus 1 into lambda is lambda minus lambda whole square is nothing but lambda square. So lambda square get cancelled. So mu2 equals to what? Lambda by a square is the mu2. That means variance is lambda by a square. Similarly, mu3 equals to, formula we have to write first. What is the formula? Mu3 dash minus 3 mu2 dash mu1 dash plus 2 mu1 dash whole cube. So after substituting the values, if we simplify, we get mu3 answer is 2 lambda by a cube. The final answer we get. Okay, now after substituting mu3 dash, mu2 dash, mu1 dash whole cube, after substituting, if we simplify, the final answer we get is this one. Okay. So again mu4 is, formula we have to write mu4 dash minus 4 mu3 dash mu1 dash plus 6 mu2 dash mu1 dash plus minus 3 mu1 dash whole power 4. Okay, 3 mu1 dash whole power 4. Okay, so after substituting the values in this formula and on simplification, we get mu4 answer is 3 lambda square plus 6 lambda by a power 4. Okay, so and the next is skewness. Skewness means skewness. So skewness is beta 1. Beta 1 formula is nothing but mu 3 square by mu 2 cube. So what is mu 3? Mu 3 means here we are having 2 lambda by a cube. So 2 lambda by a cube whole square by mu 2 in the sense lambda by a square. So lambda by a square whole cube. So that equals to here 2 lambda whole square, no? So that means 4 lambda square by a power 6 into this one a power 6 by lambda cube will get. That means this both gets cancelled and square get cancelled. The final answer is 4 by lambda. So beta 1 answer is 4 by lambda. Okay, so we'll see what is skewness. So skewness completed, no? So curtices we'll see. So curtices beta 2. So beta 2 formula is mu 4 by mu 2 square. So what is mu 4? Here we got mu 4 as 3 lambda square plus 6 lambda by a power 4. Okay, so 3 lambda square plus 6 lambda by a power 4 whole by mu 2 means, so here mu 2 is lambda by a square. So lambda by a square whole power square we are having. So that equals to 3 lambda square plus 6 lambda by a power 4 into here a square whole square, no? So a power 4 by lambda square. This both gets cancelled. The final term is 3 lambda square plus 6 lambda by lambda square. Okay, if we separate these terms, 3 lambda square by lambda square plus 6 lambda by lambda square. These both gets cancelled. So the final and lambda get cancelled. 3 plus 6 by lambda is the final answer, beta 2. That means curtices. Hope you all understand gamma distribution second kind. If you are newly watching my video, please subscribe for latest videos and also share with your friends. If you like this video, please don't forget to click the like symbol. Thank you for watching. Have a nice day.